Hello everyone, welcome back to my channel. Today we are going to solve another interesting problem from linked list. Prior to this, we have already solved the first problem in the linked list series, and prior to this, we have already completed the 10 problem from the array list. You can follow this list and try to solve each and every problem. The link for each of the problem is listed over here. Other than this, we are also planning to cover all the different categorized problem like two pointer, sliding window, strings, trees, stack, queues, dynamic programming, backtracking, cryo, greedy algorithm, graphs, all mainly the companies which is hiring on the basis of data structure. Now, without a further ado, let's get jump in and try to solve the second problem in the linked list series. So we have given a head of linked list and determined if the linked list containing any cycle or not. There is a cycle in linked list if there is some node in the list that can be reached again by continuously following the next pointer. Initially, point of POS is used to denote the index of the node tells next pointer is connected to that node. POS not passed as a parameter. Okay, so you can consider that POS is definitely not passed as a parameter. So we have just given the head of linked list and we have to find, okay, can I find the next element? Can I find the next element? Okay, now let's try to understand. For example, in first example, 3 2 0 -4 and -4 is again pointing to 2. So in this case, I can easily say that my open eyes that yes, there is a link, there is a cycle is exist. Same goes with the second example. Yes, we can say there is cycle exist, but when it comes to third example, we can't say that whether cycle by our open eyes we are not able to see the cycle. So it's the cycle doesn't exist in this loop. Now, just trying to understand what the problem is and what is expected from this problem for us. So, for example, this is our linked list 3, 2, 1, 4, and then 4 is again pointing to back to 2. Okay, so I am assuming that there are some addresses because whenever pointing, there is a pointer which is being stored so that it can refer to the next, it can refer to the next, it can refer to the next for each and every node. So if we see the struct node, so how struct node is be defined, if we see that it's containing val, then it's containing the address of next node. Okay, so what we want to do, like, whether I have to find the repeating node or not. So I'm pretty sure that whenever I'm declaring a node, then the address of that node will fix, it won't gonna change. Okay, so I'm assuming that you can just consider that because it is something that it's not in my hand, but I'm assuming that for 3 the random access will be stored like 2xxx, right? It can be stored differently. Yeah, it can be stored differently, but I'm assuming that okay, it can be stored like this. Okay, so for this also it can be stored like 4 double x 63, right? Okay, 7 double x 22, and 4 also double x 0001. So something like that, we can be storing address of the next node, we can store the address of next node. So what I will try to declare a different data structure where I can store this address, and when I find the same address again, I can easily say okay, we have already find the linked list where we have a cycle in that linked list, right? Simple. Okay, if I will take the different example like the another example 1 2. Okay, and 2 is again backing 1. So for example 1 is definitely containing 2 2. 2 is definitely contain 3 3. We don't know, right? It is just a random, right? It is just a random memory. Okay, it is just a random memory. So when first is there, I will try to see okay, is there any first already exist in our data structure? If not, I will try to insert. When I move to second, then I will try to find okay, is there any some similar kind of address we have allocated or not? If not, then we'll insert. Then when we'll go back and I will try to see okay, the one is already stored there in my for the address is already allocated and that is being tracked in my data structure. Yes, so that's how the simple intuition behind is that. So what I will do, I know that I do have simple data structure which will make sure that my order won't get disturbed, but I can store the address quite easily. And I wanted to do the operation like insertion and finding the node is exist or not in a minimum time complexity. So a set and another set are two different data types, which is automatically making sure that the insertion and finding will be doing by O of 1. So I will straight away use that set. Let me try to solve the problem in front of you now and then you can understand. Okay, so I will declare an ordered set because I don't want anything to be in a sorted order, so I will declare an order set only. Unordered, ordered. Okay, an ordered set. then I wanted this entire node to be declared. So this node star, and then I will declare as a set. Okay. We also need to declare any, whether the cycle is founding, or whether we found the cycle or not, right? Okay. So we found the cycle in that or not. So simple as. So what I will do, uh, I will declare another list node. So in order to make sure that that will be moving from my head, I will point current as the new head, as the head. My head would be there, and I will just try to use the while loop because I wanted to move one by one by one. Current is not equal to null, right? Okay. And I also need to return false. If I didn't find anything, then I will straight away return false. If est dot find, okay, what current, if is not equal to null, right? Est dot end. I think in that case we didn't find the, if it is null, right? If it is not null, then means we found the cycle, then we should return it true. If not, right? If not, because we didn't find that in. So I need to insert that est dot insert current, and I need to move my current to the next. Current is equal to current tends to next, right? I think let me see that whether this is working perfectly fine or not, or is there anything which is not working over here? Yeah, you can see that I'm able to run this, and let me submit this. Okay, so we were able to submit this. Now let me do the last step, that finding the time and space complexity. What is time complexity? So we are moving the entire linked list. We are trying to find first node, second node, third node, up to the last node. Okay, so time complexity, clearly we are moving up to the end node, so time complexity is definitely open. Space complexity, is there any data structure we are using? Yes, we are using a different data structure to iterate and find me. So I do, and in this we are storing all the element except the last, or where the cycle begins. Okay, so what I will do, the space complexity for this is O of n. Okay, this is the brute force solutions where we are using the third data structure to give me the answer. Is there any something which we can improve? Right now we got the solution. The next thing is that trying to find, can we improve this or not? Okay, so can we optimize the space? Do we require a space to be there? That is the improvisation we can do. Right now if we can see that 1 2 3 4, or how many is there, right? So do we really require to have this type of different data structures to use, or can I use the different data structure in order to make sure that I'm using something different? So what I will do, I will use the, we require two pointers. Okay, so this is slow. Currently I'm targeting it as a first, and this is my second pointer, which is also I'm trying to declare it as a head only. Okay, so what I'm doing, I'm declaring two pointers. The first pointer will be my two, firstly that by two nodes, second pointer will be my two nodes. Second pointer will move by one node only. Okay, now let's try to understand the problem statement and how we can solve that. Okay, for example, this is my node 1 2 3, right? And these are my two pointers. For example, this is my slow, currently it's a head, and this is my fast pointer, it is my head. Okay, so both the pointer currently, right, both the pointer are targeting here only. Okay, so both the pointers are only targeting here. So both slow and fast are starting at the head only. What I'm doing in the first iteration, what I will do, I will try to move slow by one step. So slow will go here, right? And my fast will go by two steps here and here. So my slow will be, when in the beginning slow is slow and fast both are here, but in the first step slow will go here and fast will go here. If there is cycle, my slow will move here, but my fast will move here and here. So in the third step it will try to find slow and fast at the same point. If it is same, right, if it is pointing like this, then in that case slow and fast will be coming at the same point. As and when we see both the pointers hitting the same pointer, then there is definitely a cycle. If not, because we can see that uh, here it will try to move, it will try to move, it will try to move, and it will be null. So my head will be first pointer will be null, but we don't want to do that. We wanted to find whether both pointer are matching or not. When they are matching, when they are equal, then in that case there is definitely a loop. Okay, so let's try to understand with a different example. 2, 3, 5, and then again 3. So we need to find whether we are able to find a pointer or a cycle in this or not. This is slow pointer and this is fast pointer. In the first iteration, what it will do, in the first iteration what it will be doing, let me just copy this and I will paste it now. Okay, so I think I didn't copy well. Copy, paste, right? Okay, now at the beginning my slow is here. My slow will come here because its slow is moving by one pointer, right? My slow is moving by one pointer. My slow will come here and my fast will go here, right? In the first goal. Second goal, what it will do? Let me copy it again. Okay. My slow is here currently. My slow was here initially, right? Here, slow was here. So my slow will be moving to the next step. My slow will move moving. Slow will move to here. Okay. My fast was here. So my fast would come here, then here, right? My fast will go here first and then it will come here. So my fast will also be all the same. As and when we see that both the pointers are hitting the same, so I will say that the loop is exist. Okay, so let me try to solve that. Let me try to do both. Yeah, so slow and head, right? So what I'm doing that I can start with the loop and I will try to write a program for this. Okay, so I will just try to move. Let me try to do fast and fast next is not null. Okay, so what I'm doing that fast is not equal to null or fast because that is moving by two steps. My slow can be waiting but slow fast can't wait, because if fast, there is high possibility that fast can be a null. So avoiding that, I have to make sure that fast and fast next should be checked. So what I will do, slow, I will try to move. Slow is equal to slow tends to next, it will try to move the first step. Then fast is equal to fast tends to next, right? Okay, okay, if slow is equal to fast, slow is equal to fast, what I'm doing straight away, because I don't want finding whether that is start, I just wanted to find whether the cycle exists or not. So I will simply return true, because that's where I need to find. Let me try to run this only, because I just wanted to find whether the cycle exists or not. I don't want to find whether when does that started. No, I just want to find the cycle exists or not. Let me submit this. Okay, so you can see my answer got submitted. Let me do the last step, that finding the time and space complexity. So we have declared two different pointers, slow and fast. So we have to have the time complexity of one, because we are moving one by one for each of the node. In the slow and fast, though fast is moving too, but it doesn't make that big difference, because anyway fast will also try to move, will try to find only of an element. And is there any something we have used to store the element? No. So my space complexity is simply O of 1. With this, we conclude the video. Thank you so much for watching this video.